The rise of the research economy, a driving force for global growth. In the 21st century, economies around the world are increasingly being shaped by knowledge, data, and innovation. While traditional sectors such as manufacturing, agriculture, and services continue to play significant roles, the rise of the research economy, where economic growth is driven by investment in research, development, and innovation, has become a major force for global development. This transition reflects a broader shift toward economies that prioritize intellectual capital, scientific discovery, and technological advancements as their primary resources. The research economy thrives on the creation, dissemination, and commercialization of knowledge, drawing heavily from universities, research institutions, and industries focused on cutting-edge technologies. In this essay, we will explore the concept of the research economy, its historical context, its role in global economic development, the industries benefiting from it, and its future prospects in a rapidly changing world. 1. Defining the research economy. The research economy refers to an economic model in which research, innovation, and knowledge creation drive growth. In this economy, investment in scientific research and technological development becomes the foundation of productivity gains, new industries, and societal advancement. This model is rooted in the understanding that advancements in science and technology fuel economic progress, and that research, when translated into innovations, leads to tangible improvements in products, services, and processes. The research economy is characterized by several key elements. High levels of investment in research and development, R&D, by both the public and private sectors. The creation and commercialization of new technologies and innovations. A strong collaboration between universities, research institutions, government, and industry. A focus on sectors such as biotechnology, artificial intelligence, renewable energy, and other knowledge-based industries. The research economy is often contrasted with traditional resource-based economies, where economic growth depends on the extraction and consumption of physical resources like minerals, fossil fuels, or agricultural products. In the research economy, intellectual capital, the ability to generate, apply, and share knowledge, becomes the primary driver of growth. 2. Historical context, from industrial to knowledge economies. The rise of the research economy is part of a broader historical evolution of economic models. In the early 20th century, economies were largely driven by industrial production, where value was created through the mass manufacturing of goods. As economies modernized in the post-World War II era, the service sector became a dominant force in many developed countries, with economic activity shifting toward industries like finance, healthcare, and education. The late 20th century marked the beginning of the knowledge economy, a concept first popularized by economists like Peter Drucker. In this model, the ability to create and manage knowledge became the central resource for economic development. With the advent of the information age, powered by computers and the internet, knowledge creation and dissemination accelerated rapidly. The research economy is a natural extension of the knowledge economy. It builds upon the notion that the most valuable economic activities are those that involve not just the processing of information, but the creation of new knowledge through scientific research and its transformation into commercially viable products and services. 3. The role of research in economic development. Research is the cornerstone of innovation. Countries and companies that invest heavily in R&D tend to lead the world in technological advancements, which in turn spur economic growth. Research-led economies thrive on discovering new ideas and applying them to real-world challenges, from improving healthcare outcomes to developing sustainable energy solutions. 3.1. Public and private investment in R&D. The strength of the research economy depends heavily on sustained investment in R&D. Both governments and private corporations play vital roles in funding research activities. Many governments allocate significant portions of their budgets to support scientific research in universities, research institutions, and national laboratories. For example, in countries like the United States, Germany, and Japan, public investment in R&D has historically been crucial in developing sectors such as defense, space exploration, and healthcare. Private companies are also key players in the research economy. Industries such as pharmaceuticals, technology, and automotive heavily invest in research to maintain competitive advantages and drive innovation. For instance, companies like Pfizer and Moderna are examples of private enterprises that have made groundbreaking contributions to healthcare by developing mRNA vaccines, a direct result of sustained R&D efforts. 3.2. Research commercialization and economic growth. While research itself is vital, its ability to translate into marketable products and services is what ultimately drives economic growth. Universities and research institutions are often incubators for innovation, where discoveries in fields like nanotechnology, biotechnology, and artificial intelligence can be commercialized through startup ventures or collaborations with established companies. The role of technology transfer offices, TTOs, within universities and research institutions has become increasingly important in this process. TTOs help researchers patent their inventions, connect them with industry partners, and facilitate the commercialization of technologies. The success of Silicon Valley is a prime example of how academic research, venture capital, and entrepreneurial ecosystems can work together to create new industries and generate immense economic value. Is particularly influential in certain high-growth industries that rely on cutting-edge technological advancements and scientific discoveries. These sectors include biotechnology and healthcare, information technology, clean energy, and advanced manufacturing. 4.1. Biotechnology and healthcare. One of the most significant sectors in the research economy is biotechnology and healthcare. Investment in medical research has led to advancements in areas such as genetics, pharmaceuticals, and medical devices. The biotechnology sector, which is heavily dependent on R&D, has revolutionized how we treat diseases, understand genetics, and develop new therapies. The COVID-19 pandemic highlighted the importance of a strong research economy, as global efforts to develop vaccines were accelerated through unprecedented collaboration between governments, research institutions, and pharmaceutical companies. The rapid development and deployment of vaccines demonstrated the economic and social value of sustained investment in biomedical research. 4.2. Information technology and artificial intelligence. The information technology, IT, sector has been one of the primary beneficiaries of the research economy. Advancements in artificial intelligence, AI, machine learning, and big data analytics have revolutionized industries ranging from finance and retail to healthcare and transportation. The IT sector's rapid innovation cycle relies heavily on continuous research into new computing technologies, software development, and data management techniques. Research in AI, for example, is transforming industries by enabling new capabilities in automation, natural language processing, and decision-making. Companies like Google, Amazon, and IBM have invested billions of dollars in AI research, which has led to groundbreaking innovations in cloud computing, robotics, and digital assistants. 4.3. Clean energy and sustainability. As the world faces the growing threat of climate change, the clean energy sector has become a focal point of the research economy. Investment in renewable energy sources such as solar, wind, and hydropower, as well as research into energy storage and smart grids, is driving the transition to a more sustainable energy system. The research economy is helping to solve some of the most pressing global challenges, such as reducing greenhouse gas emissions, improving energy efficiency, and developing carbon capture technologies. Countries like Denmark, Germany, and China have been at the forefront of investing in renewable energy research, and their economies are reaping the benefits of reduced reliance on fossil fuels and the creation of green jobs. 4.4. Advanced manufacturing. Advanced manufacturing is another sector where the research economy plays a crucial role. Research in areas such as robotics, 3D printing, and materials science is transforming traditional manufacturing processes, making them more efficient, sustainable, and customizable. The integration of Industry 4.0 technologies, such as the Internet of Things, IoT, artificial intelligence, and automation, is reshaping manufacturing industries around the world. By embracing research-driven innovation, advanced manufacturing companies can reduce costs, increase production efficiency, and deliver more complex products to market. For example, the aerospace and automotive industries have made significant advancements through the application of lightweight materials, additive manufacturing, and automated assembly lines. 5. The future of the research economy. As we look to the future, the research economy is poised to become an even more important driver of global growth. Several trends are shaping the future of this economic model, including the increasing importance of global collaboration, the need for sustainable development, and the rise of digital technologies. 5.1 Global collaboration and open science. The challenges facing the world today, such as climate change, pandemics, and cybersecurity, are global in nature and require international collaboration. The future of the research economy will depend on the ability of countries to work together, share knowledge, and pool resources to address these challenges. Initiatives like the European Union's Horizon Europe program, which fosters international cooperation in research, are examples of how global collaboration can drive innovation. In addition, the rise of open science, the practice of making research data, publications, and methodologies freely available to the public, will play a crucial role in accelerating scientific discovery. By democratizing access to knowledge, open science initiatives can reduce duplication of effort, increase transparency, and foster innovation across borders. 5.2 Sustainability and climate research. As sustainability becomes a central focus for governments, industries, and consumers, research into climate change mitigation and adaptation will be critical. The research economy will continue to drive advancements in clean energy, circular economy models, and sustainable agriculture practices. Investments in these areas are essential not only for environmental protection but also for creating new industries and jobs. 5.3 The role of digital technologies. Digital technologies will play an increasingly important role in the future of the research economy. The continued development of AI, quantum computing, and blockchain has the potential to revolutionize research practices, making it easier to analyze large datasets, conduct complex simulations, and ensure the security of research data. Moreover, digital transformation will enable faster commercialization of research findings. As new platforms and technologies allow researchers to connect with industry partners, investors, and consumers more effectively. Conclusion. The rise of the research economy marks a fundamental shift in how economic growth is achieved in the modern world. As knowledge and innovation become the driving forces of progress, investment in research and development will continue to play a critical role in shaping the future of industries, societies, and global economies. The research economy not only fuels technological advancements but also addresses some of the most pressing challenges of our time, from healthcare to climate change. By fostering a culture of innovation, supporting global collaboration, and investing in key sectors such as biotechnology, clean energy, and information technology, the research economy offers a path towards sustainable, equitable, and resilient growth in the 21st century.